For section 6.3, there's a couple ways of approaching this. You can still factor if you have something a little more complicated logically. The problem is it really starts getting more complicated as the numbers get bigger. But I'm going to start with that because there are a lot of people that really just will continue to factor these logically. They'll kind of put the blood, sweat, and tears in it. So logically, here's the idea. If I look at this first, I say, well, what can multiply to make 6r squared? The problem here is that there's two options. It could be 6r and r, or 3r or 2r. So you actually have to consider both, and you have to kind of guess and check the numbers in there until you can find something that makes that r in the middle, okay? So second, I still look at the 1, what multiplies to make 1. Well, it has to be 1 and 1. And when I go to check it, I go, alright, this is going to obviously give me my 6r squared, but this is going to give me 6r and 1r. And can that 6r and 1r make a 1r in the middle? No. Then this didn't work. And if there were more options besides 1 and 1, we then have to check those and switch those. And this is where this kind of guess and check method really starts to stink because it can create a lot of work. But look down here, once again, 3r and 2r can also make 6r squared. So we try the 1 and the 1 there. And when I check that out, obviously that's 6r squared still. But now I have 3r and 2r. 3r and 2r could make 1r if that 2 were negative and the 3 were positive. So 3 times positive 1 and negative 1 times 2. And now this would actually work. Okay? So this would be our factored answer. You can still guess and check, but like I said, it gets a little more complicated. Sometimes you may have, 10, 15, upwards of 20 different things you have to check. This one only had a couple, but got some options. So what I'm going to do is I'm going to show you another method. It's just really a beautiful way of handling this and kind of structuring it. It's called factoring by grouping, or it's called AC factoring. Okay, and what you do is you take the A and the C, 6 times negative 1, and you put a negative 6 up there. And then we take the B, the 1 in the middle, and put it down there. And we do this like we did before, where we say what multiplies to make 6 combines to make 1. Well, that would be a 3 and a 2. And to make a positive 1, the 3 would need to be positive, the 2 would need to be negative. What we do is, these used to be our answers, like we would just go, oh, this is easy. It's just r plus 3 and r minus 2. That's not right this time because r times r would not give us 6r squared. So we can't just go straight to doing that. What we do instead is we use these two numbers to split up that r. So r is the same thing as 3r minus 2r. And here's where you got to stop and we need to make sure we agree. Is 3r minus 2r still 1r? Okay, we haven't done anything except just kind of break this apart. So now instead of having 3 terms, we have 4 terms. Why would I ever want to have 4 terms with a polynomial here? Factoring by grouping. See, I can group the first two. What do the first two have in common? A 3 and an r, leaving us with r plus 1. What do the second two have in common? Well, negative 2r minus 1, not really divisible by anything in common, but we said this before, if the leading coefficient's negative, factor out the negative 1, leaving us with, it looks like I divided the last one wrong, 2r plus 1. I'm going to go back and fix this. Hopefully you caught me already. 3 times 1 is not 6. If I factor out the 3r, that leaves us with 2r plus 1. Okay? So this is cool because we've gone from 4 terms to factoring by grouping. These two have something in common. 2r plus 1 times 3r minus 1. What do I like about this? I didn't have to guess or check anything. It's a really nice way of dealing with this. Plus, you may have to, like I said, sometimes if you're guessing and checking, you may have 10, 15 options, and maybe none of them work. And so you have to check all 15 before you decide if something's not factorable. Here, if I use this process right, and I fill in these numbers, if there aren't 2 numbers here, then this is not factorable, and I saved myself a lot of work. So I'm going to keep emphasizing this factoring by grouping. really a vital skill. Factoring is going to be the foundation for Math 51, so you need to make sure you get strong in this skill. Alright, let's try this again. 12z squared minus 5z minus 2. Just for fun and giggles, I'm going to say, so what if I didn't like this whole factoring by grouping? You would have to go, first, what makes 12z squared? Well, that could be 12z and 1z. That could be 3z and 4z. That could be 6z and 2. Do you see where this is going to start getting ridiculous? And then I'd have to check 2 and 1, and if that didn't work, I'd have to check 1 and 2, 2 and 1, and 1 and 2. So I'm looking at 2, 4, 6 different things I may have to guess and check before I might find the answer. That's assuming it's even factorable. I hope you are getting the idea that the guess and check really has its limitations. An easier approach is this AC. See, what is 12 times negative 2? How about negative 24? And the B term is minus 5. I'm looking for two things, what multiplies to make that AC and combines to make the B. Well, 24 is 1 and 24, 2 and 12, 3 and 8, ding ding ding. 3 and 8 can make a negative 5 if the 3 is positive and the 8 is negative. The only weird thing about this is you got to figure out what am I going to do with those two numbers? That's step 2. We're going to split the bx. We're going to split the middle term using these two numbers. So that negative 5z becomes positive 3z minus 8z. Why would I want to do that? Well, what did we just do, right? We went from 3 terms to now we have 4 terms. Why would I want 4 terms? Factor by grouping. Group the first 2, group the second 2. The first 2 have 1 in common. 12 and 3 is both divisible by 3, and they both have a z, leaving us with 4z plus 1. Negative 8 minus 2, they are both divisible by a negative 2, leaving us with 4z plus 1. Now that I have 2 terms, those 2 terms have 1 in common. 4z plus 1 times 3z minus 2. Is it right? You can always check it. 4 times 3, 12, z squared. 4 times 2 would be minus 8, plus 3 minus 2. And if you put all that together, you get what we started with. I'm going to take a second. If you're not liking this algebraic, you can take these 4 numbers, these 4 numbers that we had right here, and you can do it in an area model. So you may like this. Basically, you put the ax squared up here, so the 12z squared here. You put the c down here at the bottom right. So the ax squared is in the top left. The c is down here. And then these 2 numbers are what we use to split the z. What's kind of nifty about this is I can look across this row and go, what goes into 12 and 8? How about a 4 and a z? Down here, what goes into 3z minus 2? Nothing, so it'll just be plus 1. Another way of thinking about this too is to go 4z times what now? Gives me 12z squared. That would end up being a 3 and a z. Or if I look at the column, 12 and 3 are both divisible by 3. These both have a z. So it's really kind of a nice little system where there's a lot of double checks built into it. And last, negative 8 and negative 2, both divisible by minus 2. Notice the 2 groups that we have right here are our 2 groups right here. So if you like the area model, please feel free to do that, but you still need to write your answer as 4z plus 1 times 3z minus 2. Okay, last couple. This is where the AC gets a little trickier unless you catch something first. See, all my numbers here, I'll have a lot of people do 6 times 18 is, what is that, 108. Oh, buddy. Somebody else is going to go, look, I got a 6, a 3, and an 18. Those are all divisible by factor out those like terms first. Leaves us with 2a squared plus ab minus 6b squared. So now what's my a times c? 2 times negative 6 is negative 12. My b is 1. Two things that multiply to make 12 combine to make 1. How about 3 and 4? Where the 3 is negative, the 4 is positive. What do we do with those numbers again? Split that middle term so that 2a squared stays the same. This right here splits into a minus 3ab plus 4ab minus 6b squared. 4 terms, factored by grouping. First two have 1 in common, I think just an a, leaving us with 2a minus 3b. Second two have 1 in common, a 2 and a b, leaving us with, I need a little more room, I'm sure you can all just do this too. Alright, leaving us with 2a minus 3b. I actually really like this for me because this makes me feel like I've done something right. Look, make sure something's complicated here. I draw lines. All right, because when I look at these two groups are the same. That makes me feel like I've done something right because now I can factor out the 2a minus 3b, and that leaves us with a plus 2b. Wonderful. 18, 63, 27. Please don't do 18 times 27. Oh my goodness. Oh, by the way, this is not right, is it? Somebody caught me, I hope. Look, for it to be completely factored, do not forget to bring down a 3. In fact, when I pull something out like that, what I like to do sometimes is I'll kind of draw a line and go, don't forget to bring that down. Because our final answer still has that 3 doesn't just disappear. Okay? So 18, 63, and 27, I know that those are all divisible by 3. And they all have p's. In fact, how many p's in common? How about 2? That gives us 6, 21, and 9. Now, 6, 21, and 9 are still divisible by 3. That means we did not factor out the greatest common factor of those numbers. See, 18, 63, and 27, yes, I could pull out a 3, but this says 6, 21, and 9. I could have pulled out another 3, which means I really could have pulled out a 9. If you don't like that, just pull out another 3 and multiply it to the front, but I'm going to say, no, I should have pulled out a 9, which would have made that first number a 2, this a 7, and that one a 3 at the end. That is much nicer to deal with. Still complicated. How am I going to factor this? AC on the top, 2 times 3 is B on the bottom. What multiplies to make 6 combines to make 7. 1 and 6. Split the 7. So I have 2p squared plus p plus 6p plus 3. This 9p squared, don't forget to bring it down. Okay, what's the whole point of this? Keep in mind, this p plus 6p is still 7p. But by making it 4 terms, I'm setting it up for factoring by grouping. First group has a p in common, 2p plus 1. The second one has a 3 in common, 2p plus 1. So that now these two have what in common? 2p plus 1 times what's left, p plus 3. It's not done. That's why this arrow's here to remind me to make sure to bring down the 9p squared. So that's it. You can feel free to guess and check these to death if you'd like. I would encourage you to use the AC factoring. If you need some extra help, please feel free to come ask me about it. Come to the Learning Center. There's plenty of people that can help you. This is not going to be super easy, but it's not going to get much harder than this. So keep it up.